Hello everyone. So welcome to you all in the new episode of this multiple choice question discussion. So today I'm here with some multiple choice question from momentum and collision. So let us begin the discussion from question number 1. Okay, so here it says that two objects of mass m each is moving with speed u meter per second, making an angle 90 degree to one each other. Then we have to calculate the final momentum. Okay, so for this one, what we can do in here is simply let us draw a diagram. Let's say this is the first body that is moving with u velocity and mass is m, and let's say the another object. Okay, another object of same mass. Okay, same mass m is moving with the same velocity in this direction, so that the direction between these two objects is a 90 degree. This is what is 90 degree. Okay, and let's say this is in I direction, and we can say this is in Z direction. So utilizing the concept of conservation of linear momentum, we can say initial momentum. Okay, let me just write P. P initial will be equal to P final, and here we have to calculate the final momentum. Okay, so as we need to calculate the final momentum, so final momentum will be equals to P initial, and we have to just get the initial momentum. And we are much familiar with the fact that momentum in I direction plus momentum in J direction, it's a magnitude. Okay, and if you just need to take the magnitude, the product of I and J is going to be 0, as the theta is 90 degree. That's why we can simply write m square u square plus m square u square. So if we just take the sum, this is going to be our 2mu square u square. And if we are going to just get the magnitude in here, then this is going to be under root 2mu. So the correct answer is going to be simply under root 2 of mu. Okay, so this is here. So here's something error with this. Okay, uh, 2mu, we have to get this one. So there isn't any, okay, root. So simply under root 2 mu. Okay, let us move on to another question. Just before that, I'll just clean up this area to just write down the things. Okay, so in second number, a body from height h is dropped. Okay, if the coefficient of restitution is e, then calculate the height achieved after one bounce. Okay, so suppose this is our object, this is falling down from height h, and as soon as it reaches some rigid support, it will bounce back. And the coefficient of restitution, that is the ratio of final velocity to initial velocity. Okay, equals to the ratio of final velocity to initial velocity. Everybody knows this. So the coefficient is this one. Then we have to calculate the height achieved after a single bounce. Okay, so for this one, when the object will fall down, then the object will come up with its kinetic energy, that is 1 by 2 mv square, and it simply moves through and change the it will just change its potential energy mgh. Okay, so this is mgh, and the velocity while reaching the ground is going to be under root 2 zs. So this is the velocity with which it hits the ground. Okay, so this is the velocity. So when it will be rebouncing, okay, so let's say this is initial velocity, it is striking here, and when it will bounce back, let's say this is the velocity, final velocity. Okay, so our total height in rebouncing is h1. Let's say this one h1, and the total height it has traveled in the initial case is h. Then the velocity with which the object is bouncing back is simply is going to be this v equals to under root 2 z h1. Okay, this is what our idea. And from the idea of restitution, equals to V equals to 2z h1 by initial velocity 2z h with root. So if we just cancel out, then E equals to h1 by h with square. Okay, we can do it. So the height that is going to be taken in the first bounce is going to be h1 equals to h times E square. Okay, so the correct answer is going to be h1 equal to E square h. Okay, so this is the second one. The third one, let's move on to third one. This is related to, again, like a collision. Okay, so let me just clean up the area to write down the things. Okay, so it's talking about a particle of mass m collides with another stationary mass capital M. Okay, so small m is moving and capital M is at rest. If the particle m just stops after collision, the situation is like this one. Suppose this is a small m and this is a big M. Okay, so this is the initial situation. It is traveling, but it is at rest. So as soon as it will heat, okay, so as soon as it will heat, the small object will remain stationary, become stationary, and this capital M starts to move. This is our question. So now we have to calculate the coefficients of restitution. Okay, restitution. So that is final velocity minus initial velocity. So from the conservation of momentum, we can simply write m1 u plus, okay, 0, because it is at rest, and final will be okay, first object is going to be at rest in the final state, and let's say capital M v2 will be the momentum of this one. Okay, let me just write. So v2, so the value of v2 is going to be how much is m1 u divided by, so capital M. And if you just need to calculate restitution, this E is going to be final v2 minus 0 divided by 0 minus u. Okay, so if you just substitute these values, then what we can get is mu divided by capital M all divided by u. Okay, so this simply gives us the magnitude of m by M. Okay, so the final answer is going to be small m by capital M. Okay, this is how we can solve out this question. Let us move on to question number 4. Okay, so it is again related to simple mathematical calculation. So here again we have to utilize the concept of conservation of momentum, conservation of energy, and so. Okay, so here it says that a bullet is fired and it is moving with velocity v and mass is m, and it strikes the suspended wooden block of mass m. Okay, suppose this is bullet and it is traveling with velocity v with a mass m, and here in some rigid support there is a block suspended with m. Okay, so this is the direction, and as soon as it strikes, so obviously because of this collision, this wooden block will be moved a certain height as it will be gaining certain height h. Okay, so this bullet will get collides inside and it will travel this way. Okay, so strikes in suspended m, the block rises through a height as the initial velocity of the block will be. Okay, so we have to get the initial velocity of the block. So for this one we can simply utilize the concept of conservation of energy, that is the final kinetic energy, the total kinetic energy equals to 1 by 2 m plus m times v square. Let's say it is just traveling with the velocity v. Then total potential energy as it has traveled from this location to this one, the potential energy is going to be m plus m and z times h. So if we just compare, so because of this kinetic energy, it is and this because of this kinetic energy, it is traveling to certain height h. Okay, that is kinetic energy has transferred into the potential energy. That's why you can arrange them together. So if we just equalize these two parameters, then our velocity is going to be 2z h with root. So this is how we can easily calculate the magnitude of this velocity, and the answer is going to be this one. So okay, moving on to question number 5. So it says that a particle of mass m1 is moving with a velocity v1 and strikes with another particle of same mass at rest elastically. That means the collision is elastic. The velocity of second particle after the collision. So you know well, just can utilize the concept in here. No need to do any kind of mathematics. So because of elastic collision, we need to utilize the conservation of energy and conservation of momentum, and they will simply be exchanging the velocity. So v2, the final velocity of the second particle v2, will be exactly equal to the velocity of the first particle. So this is how we can easily calculate or find out the solution for this question. So let us move on to the last question for today. That is, a body of mass m1 equal to 4 kg moves at 5 meter per second, and another body of mass 2 kg. Actually, this is 10 kg. Let me make it correct. So it has to be 10 kg. Let me make it 10 kg. Actually, it is 10 kg in question. Unfortunately, it becomes 2 kg in here. Actually, velocity is 2 meter per second. Okay. So it is another body of mass m2 10 kg moves at 2 meter per second. The kinetic energy of the center of mass of the system. Okay, we have to calculate the kinetic energy of center of mass. So first of all, we have to calculate the velocity of center of mass, and you know well, velocity of center of mass is simply m dr by dt plus m2 dr2 by dt. So this is m and this is 1, and divided by m1 plus m2. So dr by dt is the velocity of force, and dr2 by dt, this is the position vector. So m1 is 4 and velocity is 5. Again here m2 is 10 and velocity is 2, divided by m1 plus m2, that is 2 plus 10. Okay, so no, 4 plus 10. Let me just clean up. It's a bit rough. Okay, okay, this is your mass m1 is 4 plus, and this is another is 10. So this is the total velocity. And let's say this is in I direction, or in actually this velocity is given in I direction. Here is also in I direction. So this is how we can easily get. This is 4 5 are 20 plus 20 divided by 14 square. So we can easily get this one. Okay, so now we need to calculate the value of energy. So energy will be equals to 1 by 2 mv square. We can simply utilize 14 into 1 by 2 into this one is 40 divided by 14 square, this much joule. Okay, you can easily simplify this mathematics and you can get the answer for this particular questions. Okay, this is all for today. I believe you got the answer for all these questions. Stay tuned for us for more videos and more MCQ from different topics. Thank you.